My name is Michael. I'm working in the JavaFX team. I'm the technical lead for the core components, which means the properties, the binding API, the new collections, and the animation framework. And before I joined Sun Microsystem, later Oracle, I was a game developer. So today I have the great opportunity to actually combine those two parts of my history, professional history, and I want to show you how you can write a game using JavaFX. So we just have 45 minutes, so you don't expect Doom or anything like that. It's more going to be a casual game, and to be honest, it's not going to be a full game. I mean, I know what writing a game means. It's usually not a weekend job. It takes a lot of effort. But what I want to show today is how you can actually write the basic game mechanic in just 45 minutes. So enough talking. Just go over here. Does it work? Do you hear me? Sorry, hello? No? Hello? Oh, now it works. Okay, great. So I'm using NetBeans for this exercise. I'll start with a new project. And when you have a current version of NetBeans, it has the JavaFX plugin already installed. So I'll just choose a new project, which is a JavaFX application. Give it some name. And make sure that the application class already gets created. So how many of you have developed JavaFX applications so far? Okay, not so many, so I'll go through this very quickly. So what NetBeans already generated is a very basic application. When you start that, it'll just show a small window with a button, and when you press it, it prints "Hello World." So that's what what NetBeans already provides for you. I'll just quickly remove all of that. Not all of that. The parts I don't need. So we have this basic class which extends application. That's a class in the JavaFX runtime, and every JavaFX application needs one instance of this, one instance of this application class, which is your starting point. And there's one method start, which gets a stage. A stage is an abstraction. It depends on the platform you're running on. On a desktop system, you can think of a stage as a window. So you get the first window and you fill it with the content, and you can create more windows later. So down here, there's a main method which will be started in environments that don't know the application class yet, but this will probably change in the future. But for now, you can just ignore it. NetBeans generates it, and then you can just ignore it. Oops. Okay, so a JavaFX application starts with a stage. Within that stage, you put a scene which defines the content, and within that scene, you have a scene graph. The scene graph is basically just a tree, and the leaf nodes of that tree are the elements which will be visible on the screen. So let's see. We have the primary stage. JavaFX, the runtime is mostly based on using lots of properties. So you can see the primary stage. When I want to change the title, I'll set a property title. Then I set the scene, which I generated before. Just change that to something not really more meaningful, but anyway. Okay, so I'll define the screen size usually in constants, because that's certainly a better way to go. I don't know why NetBeans is not doing that actually. So these are the parameters that you pass in the constructor of the scene. So the first one, the second one is the width, and the third one is the height. And root, that's the root node of your scene graph. So as I said, it's a tree, and the root node of that tree has to be passed to the scene as well. So we can quickly run that already. Oops, not yet. Actually, I have to fix the import and have a typo. That should be it now. So now I have the scene with the right size, and it's empty because the root node doesn't have any children or anything to show. So we're going to fix that next. First, I will use images mostly for this application. Back. So here I create an image and I pass in the URL or the path to that image, and I'm using this long construct because that makes sure that it's always found no matter in how I have this application built, as long as the file is in the same folder as the source file, it will be found. If it doesn't depend on if it's a jar or if it's just running class files from the file system. And actually I have to copy those images over. It's this one. Okay. So I'm copying the image files and all the source files into the same folder. I have to find the image, and now I need to define the background. Oops, that was. Now the image view is actually the element you show on the screen, and the concept here is the image class just contains the data, and image view is the node you can show on the screen. And that is much more, it is better if you want to show the same image several times on the screen. You just load it into memory once in an image, and then you can have several image views pointing to that image, and you don't have to load it for each instance you want to show it on the screen. So now put the background image. And I'll pass that as in the constructor. And now we'll see the first image. As you can see, I hired a young talented artist to create my images. It was pretty cheap, just an ice cream, and my daughter was happy. So now we want to generate some foreground, because in the game you usually have several layers of graphics. You have a background, and you have the main characters doing whatever they're doing in the game, and then you often have a foreground. And you can do that very easy actually in JavaFX using the it's hard to talk and code at the same time. You can use that easily using the tree capabilities, because if you want to render the scene on the screen, we just traverse the tree. So you can use the tree itself to define the Z order of your elements here. Okay, just create this. Okay, now I create a new group, which will be the foreground. And I have to create the trees first. Okay, so if we do that now, we'll see that the trees are not at the right position. They're actually not visible at all because I forgot to put the foreground into the scene. So now you can see that the trees are all up here, so we have to set them at the right position. But you can see also that they are on top of the background, and that's because I put them behind in this group. This is a list, and I put it behind the, well, not a list, I mean it's a var arc, but the order of the elements define how it will be stored internally, because the background at first, it will be rendered first, and the foreground will be rendered on top of all the trees here. So now I have to move those using the translate X properties, and I have to check the values I was using here. So the translate X property and the translate Y property allow you to move the to move the elements. Okay, now it's still running. So when I run now, you can see it's at the right position, but actually it's impossible to figure out what's foreground and what's background. And to fix that, I'm going to apply some effects on the background and on the foreground, just to make it clear what is what. On the foreground, I'll add an effect. Drop shadow, and on the background, I'll put a different effect, which is a blur effect, and all of that is already provided in the runtime. You just set it, or you just instantiate it, and you set it for the node, and then the runtime will apply that effect. What was the other one? Oh yeah, and I want to make the opacity a little smaller. One would be fully opaque, and 0 would be transparent. So when I run that, you can already see, because the background is a little blurry, and the opacity was reduced. It looks really a little distant, and the foreground, because of the drop shadow, is a little closer to you now. So with that, it's pretty clear what's foreground and background. So now we have the scene set up pretty much. Now we're going to add our main character. As the name suggests, it's going to be a bird. And I have 2 images for that, because I want to animate this little character now. Okay, yes. Let's put it here. Okay, now to make the animation later, I'll need to put that in a group, and then I'm going to switch the content of that group with an animation. So I'm switching those, which means I'm going to switch those 2 images. New group. Okay, and I put it between the 2. So now you can see this thing, which is a bird. I asked my daughter twice, but she assured me it's a bird. So, start with the animation. There are several concepts in the JavaFX runtime that allows you to generate animations, and one is the concept of the timeline. In timeline, has a certain duration, and then you can specify keyframes, positions on that timeline. And for each of these keyframes, you can then specify that a certain variable should have a value, and then it will interpolate the values in between. Plus, you can also define event handlers for all of those keyframes, and then when the animation plays and hits those keyframes, the event handler will be triggered. I'm going to use that here. Now, there's a property cycle count with which you can define how often this timeline should be played. I'll set that to indefinite because I want to have that move on forever. Okay. Let's see. Okay, so here I'm using actually the builder pattern, which is available for pretty much all of the, classes in the JavaFX runtime. And with that, I can easily set up complex objects. Because if you would just use the constructor and then call the setters all the time, it gets kind of messy and it's not really nice. And so we have these builders, so you can actually put all of that in one long line. Have I used it before, actually, without mentioning it? No. And it makes the whole declaration of an object much smaller, while still making it clear which properties are going to set. So you don't have a long list of parameters in a constructor, and later you don't really know what is what. But you can see what you're actually setting here. So now I need to define 2 keyframes. One should be at 150 milliseconds, and I want an event handler. What was that? Oops, the wrong kind. Okay. Okay, fixing the imports. So this event handler has just one method I need to define, which makes it kind of, it looks awful right now, but once we get lambda expressions, this will be really easy because all of the event handlers are SAMs, single abstract method. I have just one abstract method. And so you can use lambda expressions later, which would make this whole thing extremely short. So now I take the group and then I replace the children, which is actually just one node right now. I'll replace that with a second image, and I need another keyframe, which I'll set after 300 milliseconds, and this one is going to set the first image again. Let's see. Okay, so now you can see it's flapping just by switching those two images. Now we want to make this bird fly. For that, I'm using another concept for defining animations, and these are transitions. So a transition is, while a timeline gives you a lot of control and flexibility when you define your animation, transitions are meant to allow you to allow you to specify one specific type of animation, but they do that a lot easier. I mean, using timelines gives you full control, but it's also very verbose and kind of complicated. But if you use transitions, it's really extremely straightforward. But I'm doing that in a little method which I want to use, because I'm going to start this animation from different positions, from different parts of the code. So here at the end I'm calling start animation, which should start the animation. And now I have to see, okay. So in order to access this animation, I have to declare it as a field. Private. What was it? Oh, animation current. So just to be sure that the current animation will be stopped, I'll just do that first. That was too fast. Stop this one. Okay, and then I'll have to create two random numbers, and I have to declare use the random. So, as usual in games, the quality of those random numbers doesn't really matter, so you can just do it like that. And I want this to be somewhere between the height, quarter height and 3/4 heights. And then I declare a new translate transition with these values. Oops. Oh, yeah, bird has to be a field as well because I want to access it in this method. And I have to remove the local variable here. Okay. So now I can access it here. And you can see, to define a translate transition, I just set which node I actually want to move across the screen, and then I specify the starting X coordinate. Oops, what's that? 2X. And the starting Y coordinate will be my first random number. Oh yeah, and then I need to define a duration. I want the whole thing to be 2 seconds. And to start a new animation, if the old one finished, I'll use this unfinished handler. And that's fired as soon. I don't know why NetBeans always gets this wrong. So this event handler gets fired once the animation ends, and then I'll just start a new one by calling the method. Build. Oh, I didn't explain the builder pattern to the end. So we have these builders. You call create to create an instance of this builder, then you set all of the properties here, and at the end you call build, and that generates you a new instance of this class with the currently set properties here. And you can reuse builders actually when you want to create similar objects several times. You can just declare the builder once, and then you change just the properties which are different between the different instances, and call build several times, and each time you get a new object. So here we just need one, so I'll just finish that. Let's see. So now you can see how the bird is flying across the screen. And now we want to allow, enable the player to shoot this little bird with a mouse. Yeah, I think I have to make it slower here on stage. So to do that, we can apply an event listener, a mouse pressed handler to the object itself, to the bird. So when we hit the bird with a mouse, this event handler gets fired, and that's how we trigger our, or how we measure if the player was able to hit the bird. So, I don't know, I'll just put it somewhere because I'm losing the other side on this small screen. Okay, bird, that was our group, and I set the on-mouse pressed handler here. And, okay. And what do I want to, I'll create another hit animation. I'll start that here, and that's pretty much it for now. So now I have to define this hit animation. So and for that we use another feature of the animation framework, which are group transitions. Group transitions so far, I mean, we have simple transitions. You can use timelines for complex animations, but the group transitions allow you now to take those simple transitions, for example, and then assemble them to more complex animations. So there's a sequential transition which takes a list of animations and then plays them one after the other. And there's a parallel transition which takes also a list of a list of animations and then plays them all together. And what makes that really powerful is that you can actually combine those two, and you can nest sequential transition and parallel transition into each other. So you can actually define very complex animations just by using the simple transitions and combine them using sequential transition and parallel transition. And I'll do that now by defining the I'll use that to define the hit animation. No. Sequential transition builder, that's the one I want. Okay, I have to... Oops, sorry. So again, I'll just I'll set the node I want to animate here. And then I'll define the children. For that, I'll take a rotate transition. Which, as the name suggests, rotates a node. Values were, here I specify the starting angle and the end angle and the duration again. Okay. That's the first one, and then I want to translate transition. And here I don't specify a starting value, so which means as soon as the animation starts, the current value will be taken. And I don't specify an end value, but just say it should go down by 1000 pixels. And the duration was, 800 again. Okay, so is that it? Now let's see if I can hit it. Yeah. Oops. Okay, that actually, it wasn't really what I intended. Here, when I start the animation, I have to make sure that the rotation is correct. So I'll just take the rotate attribute, because that's the one that gets changed by the rotate transition. I'll make sure it's 0 when I start something. And actually here, I wanted to, when I hit it, I want to stop the other animation. So you can see once you have an animation defined, it pretty much works like a CD player or something. You call play, pause, stop. You can jump in the animation and do all of this stuff, and it's pretty straightforward to use it that way. So, yeah. Okay, but one more thing. Once this sequential transition is finished, I'll call this unfinished. I'll use the unfinished handler again. Yeah, and again I have to write all of this crap here. Yeah. As I say, it's designed really to become really fun when we have lambda expressions, but right now it really sucks. Okay. No. I think I have to slow it down a little. Okay, so now I want to add a little display counting the shots and the misses. So for that, I'll define two JavaFX properties. Both are going to be use integers. And I have to pass in two parameters. The first one is the bean of the property, so the containing class, and the second is the name of the property. Or actually, it's kind of optional, but one should use it. Okay, and the hit counter. For that, I already have my event handler, so I take the on-mouse pressed handler, use the hit counter, and it's a property, so it has a getter and a setter. To increment it, I have to make it like this, unfortunately, right now. Maybe somebody will file a feature request to give us increment and decrement. So, and for the shot counter, I'll add a mouse event handler to the scene. So whenever the user clicks somewhere on the screen, it will increment the number of the shots he did. Shot counter dot set. Okay, now I actually want to show that on the screen. So I create two labels, the hit label and another shot label, or shots, I don't know, whatever. Need to fix the imports. And to set the value, I'm not going to do that myself in a change handler or something, but I'm using the binding capabilities of JavaFX. The binding means if you have two properties or a property and something observable, you can bind it to the property, and so whenever the observable value gets updated, the property will be updated automatically, which makes the code much easier because you don't have to think about all the cases when the value should be updated. You just define the binding ones, and then you can forget about it. So I'm doing that right now. Hit label is so text actually is another class in the JavaFX runtime. It has a property text, and which means it also has a method text property which returns this instance of a property, and that has a method bind. Now I'm using the bindings class. There are a whole bunch of very useful methods in this bindings class to generate new bindings. So this is hits. There's a concat method, and I'll put there this. Okay. And I'll do the same for the shot label. Oops. Okay, and then I have to show all of that on the screen. Oops, something is wrong. Yeah, I think this constructor doesn't exist, so I'm going to use the builder. Well, just move it down here. Okay, I have to move it a little to make it visible. Oops. Okay, I just moved it around so that it's declared already, and I'm just adding the stuff here, and there's some error. Oh, I forgot to copy the event handler here. So you can see the shots are already counting, but the hits are not. Okay, so now the hits are updated as well. And the strings here, which are concatenated, are calculated automatically. That's done by the bindings API. So what else? Maybe one more binding here. So if I want to show also the misses, yeah, I think I can't really do sound. You won't hear it anyway. So I'll just do the calculation of the misses. For that, I don't want to add a new property, but I'll just calculate it on the fly. Create another label. And this time it is going to be bound to, how did I do it? Yeah, here I'll take shot counter, and this is also part of the binding API. I'll just take the one property called subtract on that, subtract the hits, and I have to add it to the HUD here. Now you can see the misses get updated as well, and I'll just declare those bindings once, and then that's done. So I think the time is almost up. So now this is certainly not a full game. I mean, if you want to write a full game, you need to add a menu, a high score list, certainly better graphics, more levels, and all of that stuff. But what I wanted to show you here is that you can use JavaFX to write casual games. And the API is really very straightforward. You can use it straightforward when you write games, and it matches really very well what you need when you write casual games. And what I also wanted to show you here is how fast you can actually develop something. And when you write games, the hard part is actually not really coding the game, but it's finding a new game idea, a new game mechanic that's fun and addicting. And you can actually just figure that out by trying out. So you need to be able to get your ideas implemented quickly, to try them and to fine-tune them until you have the new Angry Bird or Bejeweled or whatever. And with the JavaFX, I mean, it took me just 45 minutes here to actually have the basic game mechanic of this simple game ready. And I think that's true for most casual games. So you can have a good idea in the morning, and you can actually test it already in the afternoon with JavaFX. So thank you very much.